One important thing, like I said, from my perspective, is that this is not a big sample of code. By the way, I have it posted on our Java class sample list. It's there. Very similar to this. I was coding it from head, but it's another version of it is already posted. So make sure that you're comfortable and realize how everything is related. But I'd like to show you one extra level of abstraction. Let's experiment a little bit. What if there was no database ID, right? And let's get rid of this demo. You know, we had this chat about internal implementation of it. So what if, right? And I never actually use my database ID, but I just said that the superclass shape could have the database ID. So then, by the way, before we kind of get rid of it, just a couple of aspects, perhaps, since we touched on database ID. How about this? We said that if objects are somehow populated with the data from the database, maybe we'll provide the database ID then. For now, we want to provide the database ID for each shape that we create, but just populate it with 0 maybe, or -1, which would indicate, okay, it's not unique because the object has never actually been saved to the database yet. So maybe something like that. So of course, the way to do it would be, because the database ID is private, we have to add a constructor, right? Constructor. At least one constructor. I typically say constructors because you can have multiple constructors in any class. So here it is shape, and it's supposed to take an integer DB ID, or something like that, right? So then I can say, okay, database ID equals DB ID, which is given to me. I don't know what it is, but there will be one given to me. In this case, if I save this and try to build my project, it no longer builds, because it says, first of all, is that when you try to construct circle, again, let me show you the output. It says circle Java line 9 right here. Constructor shape is in class shape cannot be applied to the given types. Recall that we said that because circle extends shape, anytime circle is instantiated, shape is also instantiated. In fact, shape is instantiated before circle is fully constructed, because typically shape will be constructed first, and then the circle will wrap itself around it in memory physically, and the constructor of circle becomes secondary. First is the shape constructor is going to be used. But with our sort of like wiring here was that we construct circle and populate radius, but we neglected the database ID entirely. Well, we neglected it because shape had a default constructor. Since we added a specific constructor which takes an integer as a parameter, the default constructor is gone, and the circle has no longer a way to construct its shape part. And therefore, we need to explicitly say super, -1. That's the database ID that we want to populate when this constructor of a circle is used, right? So this is yet another aspect that we may have to consider when dealing with these hierarchies of objects, is that this is the way for the circle constructor to first make sure that we do call appropriate constructor inside shape. Because circle really kind of like doesn't say, in C++, there is no super keyword. There the name of the superclass is used directly. In Java, there is super keyword that used to refer to the base class from which we just inherited. So similarly, I think that we need to do very similar work in our rectangle, because otherwise also we won't be able to produce any rectangles, because rectangles similarly extends the shape. And now shape says, hey, if you want shape, you have to make an explicit reference to the type of constructor that you want to use. And to make sure that you can construct rectangle and circle, you have to specify which base class or superclass constructor you want to use when the rectangle is constructed. So anyway, just a few of these notes just to give you a flavor what else is involved. And by the way, again, this is why I prefer to keep my data attributes at the top of my classes. By the way, you know, I could do this, right? And I could say, okay, data attributes. Okay, and there's my database ID. I really don't care. The whole thing is that I prefer to keep all of my data attributes and constructors together in my code, because anytime there is a change in the list of data attributes, all constructors are immediately affected. I have to revisit each constructor and make sure it still does the right thing, and make sure that all of the data attributes are populated. So my preference is oftentimes is to keep the data attributes right at the top of my classes, and typically right next to the constructors. That's just my approach. Programming language doesn't require you to do that. And I'm sure that you can find people who would argue that there would be in other situations where this arrangement is not so convenient, but you know, it's anyone's preference, right? So you typically should perhaps take a look at what people do if you work with a team, see what coding styles they're using. And by the way, people usually fall in love with certain coding styles, and it's okay to ask them questions like, why do you code it like this? Like, you know, why you do that? And many people would love to elaborate on that and give you some information. Okay, so these are the possibilities. This really shouldn't make any difference. If I try to run it, I still get the same kind of output. The program compiles and runs. This really is just kind of superficial. It's just this database ID causing me more headache than anything useful. It's just say, I'm planning this for the future. At some point, I know these shapes will be stored in the database. The database IDs are important because if I load my shape and the user modifies it, I want to be able to store it back in the database, and I need to be able to update the same record. How do I find that record? Well, because I remember what the database ID is. And so I can tell the database, update table shapes or whatever that table is, where ID is, and I'll provide the database ID. All right, so that's just, again, a bunch of kind of theorizing about those. But wanted to make sure that the superclass constructor kicks in very quickly when you deal with inheritance situations. All right, next thing I wanted to show you is this. Perhaps now I can just comment this out just to be able to demonstrate something else. Comment this out. And let's see what I can do with my shape class. What I can do with my shape class, I can, or perhaps this is what I'll do. I'll say, well, you know what? What if there were none of these data attributes here? So go back to the version of shape. Let me just make sure that I comment out super and everything, and it's still runnable. Yeah, so everything's still runnable. So this kind of begins to look interesting. First of all, before I commented out database ID, it's an interesting observation that abstract classes can have data attributes and they can have constructors. Okay, that's okay. Although the class shape is not entirely finished because abstract methods are still present there. However, you can still add normal methods to your abstract classes, and you can add the data, and you can add constructors and all this normal class business. The only restriction is that you still cannot create class shape. You have to derive an object from it, like we did with circle and rectangle, and then make sure you finish the operation business, override all the methods promised by the abstract class. And then you can create objects of the subclasses, which are concrete classes versus the abstract class at the top of the hierarchy. So just an observation, right? So having those things inside abstract classes is okay.